Hello and welcome to my R workshop. This is Dr. Joshua Lambert at the University of Cincinnati, so I'm going to be going over an introduction to R, how to use some basic R commands and utilize some R packages to complete statistical analysis and create some nice looking tables for possibly a manuscript that you might need to do. This will be very brief. It's not going to go very in depth. It's just to get your feet wet with R and hopefully not be too intimidating. So the first thing I'm going to talk about is just an overview of the files for this workshop. I have all the files on my GitHub page, which is github.com Joshua W. Lambert /R workshop. And I'll have that in the video description below. Here at this repository, you're going to be able to find the code that we're going to use for this workshop, as well as a PDF that has basically like a written description of the workshop. So if you click on that, you'll actually be able to view it, and it kind of walks you through the same process that we're about to do on a video. So hopefully you'll find those useful, and you can download those files, and if you have any questions about that, please just let me know. The first thing you're going to have to do before we get started is make sure that you have R and RStudio installed. So if you just go to Google and type in R download, it should be the first link that pops up. So if we go there, you should be able to click on this download. Under download it says CRAN. If you click on that, it's going to take you to another page, which is basically saying where do you want to download it from. So if we click on just the first link, you can have your choices between Linux, Mac, or Windows. So you'll want to go through and do that. The next thing we'll want to do is Google search RStudio. So RStudio download. So you'll want to go through, download R first, and install it, get that all set up, and then you'll want to go back and download RStudio. So if we go there, go to Google, type in RStudio download, should be the first link that pops up. We want the free version. For most people, the free version is going to be totally fine. You do not have to pay any of these prices. This free version right here is very, very powerful and can do a lot of things. So if you just click the download, it'll take you down to basically selecting what type of version do you want. Do you want Windows, Mac, or some version of Linux? For most people, it's going to be Windows or Mac. You'll just click on that, download it, walk through the installation. It shouldn't be too difficult if you installed basically anything else on your computer. Okay, so that's the overview of downloading R and then RStudio. Once you get those two downloaded and installed, the next thing you're going to want to do is go and search for RStudio. So you don't need to do any setup to link RStudio and R. It should be all the way done for you. Okay, so once you open up RStudio, you're going to get something that looks like this. Okay. So it's going to look like this, basically a blank page almost. And I'm going to just kind of go over some of the basics of R and RStudio. So the RStudio is basically a front end for R. It's going to allow you to take a look at some of the R code that you're writing, as well as the R code that you're running, the plots that you may be making, the tables, what things that you've loaded into R, such as data sets, or what variables you've defined, so forth and so on. Also, you can install packages here in RStudio very easily. So everything's really nice. RStudio makes things very friendly. And before we had RStudio, we just had basically this screen right here. And that was it. There wasn't anything else allowing us to keep track of what was going on in R. And so RStudio really makes things nice now. Like I said before, you're going to want to go and download that file from the GitHub webpage. the R workshop code.r. You'll want to download that to your computer. So once you have that downloaded, let's just go ahead and open it up. So I'm going to click this button right here. So this little file button is where we open up files. And I'm already in the directory I want to be, so I'm going to click R workshop code. Okay. And it opens up this, and we're going to come back to this in a second, but this location here is where all of what is called your R scripts are going to open. An R script is basically just written information that that is basically R code that when you select it, you can run it, and then R will actually compute something. R doesn't compute anything in the R script. What the R script is basically just like a Word file for all of your R code that you can then transfer to what's called the console. The console is where all the action happens. It's where actually R code is run and it outputs results. Okay, so for instance, let's say I wanted to do 1 plus 1. Okay, and I hit enter. So I did 1 plus 1 and I clicked enter, and then you can see R actually computed the result of that. Okay. And so this is the console, and this is where things are run. This is where output is going to happen mostly, unless it's a plot, in which case it's going to happen over here. Okay. Up here in the top right is the environment, the history, and the connections tabs. The history is basically what have I run in the R console. You can see I just ran 1 plus 1. That's what's going to show up there. In the environment, it's going to give me a list of, I'm going to go ahead and clear that out, of all of the things that are currently in my environment. So, have I imported a data set? Have I defined a variable? That's going to show up over here in the environment. Okay, and so, for instance, let's assign a variable and see if it pops up in our environment. So I'm going to I'm going to create a variable called x, and it's going to be equal to 1. Okay, I'm going to hit enter, and so nothing happened in the R console, and that's because all it was doing was assigning a variable. And over here, you can see in the environment, I get the value here, okay, of what just happened. So this x variable is now in my environment, and so I can go back over here to console and just type x and then enter. What's going to happen is, because R knows that x is in my environment, it can now give me the value of x whenever I call for it. Okay, so x, 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 and you can see it'll just pull it all day long. I can do different things with x, so I can manipulate x. I can say, well, what's x plus 1? And R will compute that. What's x plus 2? So forth and so on. Okay, so those are some basics to R. RStudio, there's a lot going on here, and this tutorial is not really meant to go a deep dive into RStudio, but at a basic level, when you're learning R, you're going to want to do it from RStudio, because everything's right here, from your R scripts, which is just your written code, to what's in your environment, what's your history, to what files you're working with, and then the console. It's all really nice and right here. So the next thing I'm going to talk about is what's called a working directory. This is really important in R. This is basically where R is working out of. And my working directory currently is, well, let's see. So to get my working directory, I can run a command in the console called getwd. Getwd. WD stands for working directory. These parentheses here, you're always going to want to do these whenever you're writing out a function in R. So if I do that, get working directory, you can see my working directory is in my documents folder. Okay, and so that means if I save files or do anything like that, it's going to save them to my documents, which is good or bad, right? I mean, it may not want it to be there. So what I'm going to show you next is how to actually set your working directory. You could do this via command in console if you wanted to, via the setwd, the set working directory, and then you could write out the location of where you want your working directory to be. But I find that to be a little bit tedious, and RStudio makes this really, really easy. So if I go up here and go to session, I can go down to set working directory and then choose directory. Okay. And I don't want it to be in documents, which is where it currently is, but I actually want it to be in my R workshop folder that I made. So I'm going to go there and okay, and I'm going to click open. So you can see it automatically pulled the file or the folder location for me and ran the code via these drop down boxes. Okay. The other thing that happened is over here under my Files tab, it also updated the working directory over here, and now I can see all of my files that are existing over there. Okay, so that's kind of nice. So before we probably get up and running, you should probably make a folder that has the R code in it as well as other files that you may be interested in accessing, and set your working directory to that folder. Okay, so working directories are important again because if you're wanting to pull in files or you're wanting to save files, it's always going to do that from the working directory. Okay, so that's kind of rule number one. Next thing let's talk about is how to actually save your work. So there's a couple aspects to this. One is you may have an R script that you want to write, and you may want to save that R script. Again, an R script is just like a Word file. It's going to be basically where you write down code. It's not executed to run, but it's going to be where you just have some information down that you may eventually want to run. So to show you how to do that, I'm going to create a new R script. So if you go up here, just like in Word, there's like a little blank white page. You can click this one and click on R script. That's going to open up a blank R script window for you. Okay, and what we're going to do now is just write, I'm actually going to just write a comment in here. And to write comments in R, a comment is something that you don't want to run. It's not really R code. It's just information for you that you don't want to execute. So, hi, this is a test. And so if you want to write a comment, you just start it with this pound or hashtag symbol, whatever you call it. And you can do multiple ones of those if you want. You just need one to make anything a comment. And so, for instance, let's say I had some R code here like x equals 1, and I wanted to make sure I commented here so that I knew what I was doing. So assign x 1 to x. Okay, so I can write that there. It will never get executed by R if I were to run that. It just pretends basically like it's not there. A comment gets ignored by R. Okay, so let's say I want to save my R script. I can just hit save. Note it's going to pop me right into my working directory, and I'm going to just call this test.r. Okay, so there you go. I can save R scripts that way. The problem with that is that you may get into R and be working, and you might have some R scripts that you're working from, and you save those. But the problem is that sometimes you want to save the information that you have been running in console. So for instance, my environment. So maybe I want to save my environment. So I want to save this environment so that later if I come back to R, I have that same environment. I have all of the variables that have been saved. So to do that, you can just go to over here to environment and click save. And there's a special type of file which specifically is centered around R environments. Okay, so I'm just going to save this as environment R. Okay, and the type of file is called an R data file. Okay, and so now if I were to close out of R, okay, and I wanted to reopen R with the same environment, I could import this environment into R and get all of the values that I've been working with. This will become, I think, a little bit more clear as to why this is important after we're kind of at the end of the tutorial. But I wanted to show you that from the beginning because it's very important that you know how to save not only the R scripts that you're working with, but also all of these values that are getting utilized down here. Okay, and in the environment, you're also going to get your history as well. Okay. So we've talked about the working directory and the R scripts window and the working environment. Next, let's talk a little bit more about the console window and some basics in R. And so we already went through adding numbers together. We can do multiplication in R by just doing the asterisk symbol. So 2 asterisk 2 is going to give us 4. I can do division just by 2 divided by 2. Just do a forward slash. That's going to give me 1. I could do exponentiation via the little caret symbol here, the up arrow looking thing, and that's going to give me 4. And I can do subtraction just like you would imagine, 2 minus 2. Okay, so that's basic arithmetic in R. The other thing that's really important in R is what are called logical statements. And so sometimes you need R to tell you whether something is true or false. And so, for instance, let's say I go through and let's see what x is currently. So x is currently 1. Well, let's make x is equal to x plus 1. So what this is going to do is it's going to make it x plus 1 we know is going to be 2, because 1 plus 1 is 2, and then it's going to assign x plus 1 equal to x. So it's going to overwrite what x is and make it 2. So if I now run x, you can see now x is 2. All right. If I add, just do this and don't assign it equal to x, note x is still 2. So I'm going to do it one more time, and so x should now be 3, and it is. Okay. So now let's say, okay, we've gone through this process, and x is equal to something, but we want to know whether or not it's equal to something exactly, or whether it's less than a value or greater than a value. So to do that, if you want to know is a variable like x exactly equal to something, what you can do is do x equals 3. Okay, the 2 equals is telling R, hey, I want you to tell me logically whether that is a true or a false statement. I'm not into variable assignment anymore, but now I want to know, is this exactly equal to 3, or is it not equal to 3? So if I run that, you can see I get true. Okay, so these types of statements are what are called logical statements in R. I could also say, well, is x less than 3? We know that's false, and so does R. We could say, well, is x greater than 3? And that's false. What about, is x greater than or equal to 3? Well, that's true, and R knows that too. So that's basic logic statements in R. And so what we're going to do next is talk about R packages. But before we do that, I just want to make a quick statement. R is what's called case sensitive. So you want to make sure that if you're referring to something, that it's either correctly referred to as lowercase that thing or uppercase that thing. So for instance, currently x is equal to 3, but uppercase x is nowhere in our environment. Okay, so you want to always make sure that you distinguish correctly between upper and lowercase in R, because that's going to be very important. Okay. Next, what we're going to talk about, like I said, is R packages. Now, one of the things that makes R packages so important is the fact that you can take these very complex statistical methods, or these really nice R codes, and import them for free, and load them up, and they almost just work just like any other type of R code. And so R packages are really one of the best things about using R, is that you've got close to 10,000 packages at your fingertips at any one time to be able to pull in and utilize. So I'm going to show you now how to install some R packages. And there are 2 packages that are related to this tutorial. One is called Inane A, the other one is called Table 1. Inane A is a R package that allows you to easily access the Inane data sets. Inane is the National Health and Nutrition examination survey. And this is a survey that's been given for the last 20 years almost now, to individuals, to a different sample of individuals across the United States. Multiple thousands of people per year participate, and it tracks all type of information from your blood levels to, whether or not you had a common cold, which we're going to get into in a second. And so the Haynes data sets are very rich and can be really great for just exploring various research ideas. The other package here is called Table 1. And what Table 1 is commonly in a paper, if you're writing a paper, you'll need to produce what's called Table 1. And Table 1 is basically a descriptive table that's going to break down the descriptive information of the variables that you're interested in. So for instance, if I'm looking at vitamin levels, and for those that had cold and did not have a cold in the last 30 days, I would want to know what's the average vitamin levels for those two groups of people. And so a table 1 would be a perfect place to put that. Okay, or maybe also in a table 1 would be how many people are in the data sets, what's their average age, what's the breakdown in terms of race and sex and so forth and so on. So the table 1s are very important, and there's an R package that really creates these very nicely, and we're going to learn about that. Okay, so there's a couple of different ways in RStudio to install R packages. The first way is just to type in a command called install.packages, and then in parentheses you write out the name of the package you want to install. The thing is, you have to know what that is beforehand. The other thing that isn't in this code is you need to put quotes around the name of the package that you want. So I'm going to do that for both of these. So I'm just going to copy that, and I'm going to paste it down here in my console. Okay, so that's the beauty of the R script, is you've got all this code written up there, and then you can just copy and paste it. What I could have also done, if I didn't want to copy and paste it, is I could have gone to the line, put my cursor on that line, and just hit this run here. So this runs the current line. So if I do that, you can see it's going to install that package, as well as all of the packages it depends on. So for instance, that package in Haynes A depended on HTML widgets, Lattice Extra, AcePack, HTML table, this one, and this one. Okay, so it depended on a lot of things, and so that's the nice thing, is that these packages build upon one another, and before you know it, you have this big, complicated environment where you're able to do some really complex things with only a couple simple lines of code. Okay, so that's that way of installing it. I could just write out the code in my R script, click run, and it installs it. Maybe you know what package you need to do. The nice thing is that you can go to Google and you're curious, is there an R package for Google search trends, which there is, by the way, but you could go and just type in Google search trends R package, and it would come back with probably a name of an R package that's going to allow you to easily, search Google Trends. So that's kind of nice. The other way you can install packages besides the command line is you can go over here to where your files are at. There's a package tab, and you can go to install. And what you can do is it's going to default to these choices. You can just leave these the way they are and just type in what you want. So we want to download table 1. So if I type that in, you can see it auto completes it, and I want to check and make sure that install dependencies is on, and then it's going to install table 1 for me. So once they're installed, that's great. It's just like any other package or any other thing you would install on your computer. You don't just install it and then you get to use it. You have to load it. And so to load these, what we do is we do library and then the name of the package inside the parentheses. So if I do that, library, so I'm just going to do run, and you can see it runs it below here. Sometimes you might get some warnings about, hey, this is built under some other version of R. Shouldn't be that big of a deal. it's still going to be a lot. It's still going to allow you to use it. Okay. The next thing I want to talk about is the help function in R. So the help function in R is really great. I use it all of the time because you've got all these packages and these functions, and it's really complicated, and you might not always know, how do I do this, or how do I do that, or how does this function work, or how does that function work, right? And so the help function really, really comes in handy. And what you can do is there's actually a help tab, so you can go to help, and you can search up here for any topic you want. You can also do this from the command line. So I could come over here and say help table 1. Okay, and it takes me to a help package that the person who made this, or help file that the person who made the package created. So this is describing basically what does this package do, and then some of the common functions that people use here. Okay, so the help function is really important. The other thing you can do here is I can do help, and I can do linear. Okay, I can do linear. Okay, so let's say I'm interested in finding a function that does linear regression. So what I can do is this help function here is only going to look for functions of the name linear. So there are no functions of the name linear that exist in R. But what I can do is I can search for the word linear in any of out of all the functions that I currently have in my R version. So to do that, you can do question mark, and then what you want to know about. So I could do linear regression. Okay, and I put that in quotes, and then you can see here all of the different functions that exist that have linear regression somewhere in their description, right? So let's see if we can actually find the one that really does it. Turns out there's a lot of things in R that do linear regression, and I can't find it, but we're going to talk about it in a second. The nice thing is too, the help function in R is really great at telling you about a specific function. You can also, as you probably know, can use Google to search how to do linear regression in R, and you're going to get 5,000 different hits on how to do linear regression in R. Okay. So what I just did there was I cleared out this console. So if you want to clear out your console, if it's kind of cluttery, you can just do Control and then L, and that will clear it out. So I have like something on there. I can just Control L, clears it out. Okay, so next thing, let's talk about some of the functions that are within the R package in Haynes A. Okay, in Haynes A, like I said, searches the in-Haynes data sets for different things that are contained within its files. And so one of the functions that is within Inane A is called Inane Search, and what it allows you to do is search for terms that you may be interested in. So possibly I'm interested in doing bladder research. So I want to know, is there any variables or any data sets related to bladder? So I can do that here. So what this is going to do is it's going to run the Inane Search. It's going to search. The search terms are bladder, okay, and it's going to assign it equal to NH search. Okay, that's what the equals is doing. The nice thing about RStudio is that if I can figure out what these functions are going to do, again, by looking at the help file. So I can do help Haynes search. Help Haynes. Let's make sure that the packages are loaded. So Looks like I had a problem installing Inanes. Let me do it again. Okay. Looks like I'm having a problem. Sometimes R gets finicky and you need to restart it. So if you go to session and do restart, it should load everything back the way you had it. Sometimes it just needs a reset. And so if I do library in Haynes, well, it's still not liking me. So packages. Okay, I think we're good to go now. You shouldn't have that issue. Not sure why I was, but anyway. Now let's say I want to search for Inane Search. You can see it always pops up when you type all the possible things you could search for. So Inane Search pulls up a help file of what this is, and the description is: the description in the master variable list will be filtered by provide search terms and retrieve a list of relevant variables. The search can be restricted to specific survey years by specifying why start or why stop. So what it gives you then next is the usage. So this is how you use it. Okay. The first thing you need to give it is some search terms, which is just a list of terms or keywords. Some words you may want to exclude from your search. Okay, and you do this by doing exclude, or you do it by doing a comma between the commands that are within the function. So search terms equals bladder, and maybe I want to exclude terms. So I pulled that drop down box by doing a tab. So exclude, and I hit tab. It auto fills up for me. Maybe I want to exclude any words of dog. I don't want dog in my search. And I could also do, okay, I only want to start with years 2002, and I want to stop with 2009. I could do that if I want. I'm not going to, but that's what I could do. Okay, and so you can see basically you can give this function Inane Search different inputs or arguments that will then go out and run this complicated code in the background and pull down all of the things that are related to Inane Search. Okay, so I'm going to just run this. So I'm going to go up here and click my run. It's going to take a second because again it has to go out and search through thousands of data sets that are related to Inane. While that's doing that, I'm going to talk about the view function. So the view function is really nice. So this is going to come back and give a result. And if I had not assigned it to Inane Search, what it would have done is just spit out all of the information here into the console, which wouldn't have been useful to me because I would have had to scroll up and down, and I wouldn't have been able to recall it because it wouldn't have lived in my environment under Inane Search, NH Search. But now I have assigned it to NH Search, and so now I can call it back as much as I want. I can access it. I can look at it. Okay, we can go over here and look and see. Oh, Inane Search is 39 observations and 8 variables. So there's 39 variables related to bladder. And there's 8 pieces of information about each one of those search terms. So let's look at that data set, and by doing view NH Search. So if I run that, the view, you can see I get the variable name, the variable description, which data file it's in, the description as far as what the data file is coming from. So you can see I've got it coming from kidney conditions, medical conditions, so forth and so on. The years that this file ran, okay, or it's coming from, the end year, the component, and then constraints that it might have. And so this is kind of cool, right? I've got some variables now that are related to bladder, and I could go through here and highlight these and see what they are. So for instance, if I just move my cursor over this one, it says this one's after urinating, passing water, does your bladder feel empty? So there's a question that probably thousands of people answered about that specific question. Okay, so moving on. So that's great, right? I can go out and I can search in Haynes using this function from this R package. That's really great. And I pulled that all down. And I can access it. So that's kind of the beauty of R packages, right? And this is just one of 10,000 packages. There's many more out there that will allow you to access data or to do complex things, and we're going to talk more about those as we go. The next thing I want to talk about is how to read data in, and later we'll talk about how to write data, how to save that. So to read data in, you can do it in a couple of ways, right? You can do it via the command line like I have here, okay? So this is called the read.csv function, and this is in base R. I don't need any packages for this. And all I do is I type out read.csv, I tell it the location of my file and whether I have a header or not. This one, the way I've written this one is I actually need to know the location of the file. I could also have done this version, so the file.choose function actually will open up a window and allow you to go and find the file. Okay, and I'm not going to run these right now because I don't have any files to import, but you could use these if you wanted to read in data. It's really easy. This is CSV. R has can read in text files and Excel files and all kinds of files, and so the easiest way to import files, in my opinion, is actually via the RStudio buttons that are involved. So you can, if you go over to Environment, and you'll find this button called Import Dataset. And if you click on it, you have some options here. So you can import text files, Excel files, SPSS files, SAS files, and Stata files. So if I click on those, let's say I want to import an SPSS file, I just go to Browse, I find my file, and let's see if I can find one really quick here. So fall, classes, data sets. Let's see. Okay, yeah, I've got one here. So let's see if this works. I'm doing this on the fly. So you can see, there you go. And now I've got a preview of what the file will look like. Also, what code would be needed to actually import that file. And I have some other options here. I could hit import if I wanted to. I'm not going to, but that's how I would import that file. And I like using that, and that's usually the way I want to do it. And if I do end up doing that, I will typically copy the code over and paste it in an R script so I could use that later. Because the thing is, if you're not consistent with how you're importing data each time you get in and work with data, sometimes you can make mistakes and with the data accidentally. And if you import it one way this way and one way another way the other time you're using it, sometimes those inconsistencies can lead to data errors or data differences that can change your results. So you want to make sure you're consistent. Okay, so the next thing we're going to talk about is how to subset your data. So let's say you pull in this big data set, but you're like, I don't need all of that. I really just need this variable. And you want to be able to access that and use it. Okay, and so to do that in R, it's really easy with the subset command or function. So this is a built-in command. You don't need a package for this. And what we're going to do here in this example is we're going to be utilizing the mtcars data set. Now, mtcars is a data set that's in R by default. It's like an example data set that they just include by default. And let's take a look at it. So I can do the view mtcars. Okay, so if I do that, you can see it pulls up. Looks like this is a data set about cars, right? And I can scroll down through it. Looks like I have 32 entries and a number of different variables. So I'm going to go ahead and close out of that. The other nice thing is too, for anything that's built into R, it should have a help file. So I can do help mtcars. Oh, look, and there we go. So I now have a description of the file, right? And what each different column means. So I have miles per gallon, number of cylinders, displacement, so forth and so on, as well as where these files came from. So this was extracted from a magazine looking at fuel consumption. So what maybe we'd like to do is I'd like to pull out the miles per gallon for all of the cars that have automatic and manual transmissions. Okay, so if I just look at these files in their raw format, so if I do MT cars, okay, and let's say I want to access the first column of that file of MT cars, what I can do in R, and this is for anything that's a data set, you have rows and columns, right? So the way you access those in R is you put the first number, comma, the second number, the row, the comma, the column. So if I want to access the first column and everything that's in the first column, I can leave the first value blank, and then I put the name of the number of the column I want to access next. Okay, and you can see if I do that, it spits out all of the miles per gallon. Okay. And that can be, that'd be nice to get those values. I could also get the number of cylinders. If I, also in RStudio, if you click up, you will get the previous things that you have typed into search, or typed into your console. If we do comma 2, I'm going to get all the number of cylinders. Okay. So this is how you access data within a data set in R. You could also, if it's a certain type of data set, called a data frame, or a data table, you can do use the $ symbol. So $, and then it will give you the names of those columns. So I can do MPG. So MT cars $ MPG will give me the same thing as MT cars bracket comma 1 bracket. Okay. So this is going to be important, but let's say I don't want all of the MPGs. I want only the ones where AM transmission is equal to 0. So remember, we're going to use our logic symbol here. So we want all of the MPGs where this is true. Okay? So if I do MT cars $AM equals 0, watch what happens. It's going to return back false, 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 true, 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 true. So it's all of the rows where that was true, where AM, where the transmission was equal to 0, where we have an automatic car. Okay? So doing the subset, the name of the data set, AM equals 0, and select equals MPG. If I run this, what this is going to do is it's going to pull out all of the automatic MPGs. So if I do auto, you can see now I've got all of the automatic cars and their miles per gallon. So that's nice, right? I could also do it instead of 0, I could do 1. This is going to give me all the manual cars. Okay, so if I run that, oops, I'll get all the manual cars, and that's great, right? The other nice thing about the subset function is that I can select more than one column. So maybe I don't want MPG, but I want MPG, AM, and VS. And so you can just put that into what's called a list. So list and R are, as they sound, they are list of different things. So for instance, I can make a list of numbers by using the C command. C parentheses 1, 2, 3 is going to give me a list of numbers 1, 2, and 3. I can do C of 2, 3, 4, 5, C of 6, 7, 8. Okay? So those are lists. And so if I give a list of the variables I want from MT cars, I can, of MPG, AM, and VS, I'm only going to get these columns, and I'm only going to get it for the manual transmission types. Okay, so if I put my cursor on that line, and then I do EX, and then I do view EX. You can see I only get the manual cars, and I get those 3 columns I wanted. Okay, so this is a nice way of being able to subset the data down in a very easy way. Okay. So next we're going to go into the fun stuff, and we're going to jump into some Ttest and Chisquare Test, and then finally we're going to look at an example with the Haynes data. All right. So let's say, what we had just done was we pulled out all of the miles per gallon for the autos and the manual transmissions. So one of the things that would be really easy to think about is the average miles per gallon for automatics different than the average miles per gallon for manual cars, right? And so I can do that here. There's a built-in command called Ttest. What it does, it takes 2 lists of information. So in this case, it's auto. It's going to take our auto values, and it's going to take our manual values. Okay, and it's going to take both of those. And then I have to give it 2 lists of information. And then I have to tell it, okay, do I want to do a one-sided test or a two-sided test? Then what am I comparing the differences to? So the differences in the averages, do I want that to be compared to 0, or do I want it to be compared to something else? By default, it's 0, and most of the time we're interested in is it different than 0. Then paired equals false. var equals paired is paired or unpaired t-test, and var equals is whether or not you want to assume the variances are equal or not. This is, you can assume it or not assume it. It's kind of up to you. Sometimes I'll like to look at some sort of box plot first to see whether or not I should be making that assumption. But anyway, moving on. Then the confidence level that I would want to go with. So the confidence level of 95%. Okay, so if I run this, I'll hover my cursor over there anywhere on that line and click run. You can see it ran, but it didn't spit anything out to me yet. And that's because I've assigned it to a variable. I used a different assignment function here. In R, there's the equals command, and then there's the less than dash command. These essentially are the same thing. So if you see less than dash, it's the same as an equal, essentially. So if I rerun it, it's going to give me the same thing, and then I can run TT, and it's going to spit out to me what the result of TT is. So if I do that, you can see it did a Welch's 2-sample t-test, the t-value, the degrees of freedom, the p-value, the alternative hypothesis, what the averages were, and the confidence interval of the difference, and so forth and so on. So turned out that the mean of X, so the mean of the auto miles per gallons were 17, and the mean of the manuals was 24. So those seem to be pretty different. And the p-value is also quite small, so we would probably reject the null hypothesis to conclude that there's differences in the averages of those two groups. But moving on, let's say that I didn't want to do the variance equals assumption anymore, or I did want to do the variance assumption. I could do that, so I would just turn that to be true. So capital false and capital true in R are like numbers. They mean something. So if I do lowercase true, it means nothing. But capital true is a real thing. It's something you can compare something to. It's the value of true. So that's important to know. And so sometimes functions will depend on something being false or true, and you need to make sure that it's capital F false and capital T true. Okay? So if I run this now with the variance equal assumption, let's look at the result. So run that. You can see the result didn't change, but that's how I would get a equal variance assumption t-test. Okay, so we already talked about the help command for MT cars and how to access the data set AM and VS. And so again, if your data set is a data frame or a data table, then you should be able to use the $sign, but you can always use that bracket comma business. And so
I can learn to understand you much better if I can get familiar.
So for instance, before we did the first column, what if we wanted the first row? So we wanted all the information for the first car. So I could do empty cars bracket 1 comma. So that's going to give me everything from the first row. So I get everything from the Mazda RX-4 right there. So I could do, what I could also do is I could say, what if I want the first 3? Well, I could do 1 comma 2 comma 3 in a list, and that would work. Okay. The other thing I could do is I could, there's another way to do 1 through 3. That's 1 colon 3. So if you do any number colon the other number, it's going to give you back a list of all of the numbers that exist between the number you started with and the number you end with. So for instance, 1 colon 3 is 1, 2, 3. 4 colon 7 or 6 is 4, 5, 6. So let's say I did empty cars bracket 4 colon 6. I could get the 4th, the 5th, and the 6th row from that data set. Okay, so there's a lot of tips and tricks like this. We don't have the time for all that today, but that really make accessing data in R very useful and valuable. Okay, so we did a t-test. Now let's talk about a chi-square test. So a chi-square test is when we have a categorical outcome, and we also have a categorical independent variable. We want to know, is there any association between the frequencies of the occurrences between the independent variable and the outcome variable. Okay, so what I can do is I want to know, for instance, let's say that I'm interested in, is there any relationship between the engine shape, whether it being V-shaped or straight shaped, and the transmission. So so basically what we mean here is, are V-shaped engines more likely to be automatic or manual transmissions? And are straight engines more likely to be automatic or manual? And is there a difference in the frequency of the V-shaped and the straight as far as whether they're automatic or manual? So the first thing you have to do a chi-square test is you have to do a table. You have to actually compute a table. And tables in R are very easy. This one, I'm going to make a table where one of the rows are going to be the type of engine it is, and the transmission, the columns are going to be the type of transmission it is. So you just I could put whatever I wanted in here. I could put this to be ENG, and I could do this as trans for transmission. So if I do that and I sign it equal to tab, so I do equals, and run that, you notice nothing happened, but that's because, again, I assigned it to something. I need to tell R that I actually want it to spit it out to me. I get this. So again, engines are my columns and trans is my column, or engines are my rows and trans are my columns. So I have engines equals 0. So these are all the V-shaped engines, and these are all of the straight-shaped engines. And so what we want to know is, are the transmission types happening at a different frequency for the 0 engine types than the 1 engine types? It looks like they're different, right? 12 and 6 compared to 7 and 7. This is about 50-50 split. For the 1, the engine type of 1, that's straight engined. And it seems like the V-shaped engines are more likely to be automatic transmissions. So that's an interesting test. So we want to know, is that essentially, are these two variables related? And that's what a chi-square test will allow us to do. So now that I have my table made, all I have to do is chi-square.test of tab of my table. And so if I do that and I click run, you can see it spits out the chi-square value, the degrees of freedom, and the p-value, right? And so the p-value is not significant. And so anyway, that's because we don't have really that big of a sample size here. All right. So that's how that works. That's how the chi-square tests work. So next we're going to move on to an Haynes and linear regression example. So the first thing we're going to want to do is search for the term flu. And let me back up for a second. So when I knew I was going to be giving this workshop, I wanted to give an example of how to use an R package to do something kind of complicated or complex, which is to use these Haynes data and pull down kind of interesting information and test using R whether or not there was a difference between the two. And so I've been working on the Haynes data for basically the last 4 years, whether it was with my dissertation or multiple different projects. I've used the Haynes data a lot, and I know that I know a lot of the variables that exist in there. And so as I've worked with this data set over time, I knew that there was a variable that asked participants about whether they had a common cold in the last 30 days. And so one of the hypotheses I've had in my head is, I wonder if there's vitamins that are, vitamin levels are related to whether they had the flu or not. So are vitamin levels that you have today related to whether or not you had the flu in the past, right? And so that's what this example is going to be looking at. It's going to look at, do we have variables that are related to whether the participants have the flu, and then also what vitamin level information do we have in the Haynes. So the first thing I'm going to do here is I'm going to search for the term flu in the data set, okay? And if I do that and assign it equal to flu underscore Haynes NH search, I'll get that and I'll be able to view it, and we'll be able to kind of look and see what variables exist out there for us to pull from. Alright, so that's done, so let's view it. So I'm going to click run. You can see it returned a number of things. 42 different questions were related to the flu. And so for instance, did you have the flu or pneumonia or an ear infection? That started during those 30 days. So basically in the last 30 days. And then we have questions about in the past 12 months about sneezing and runny nose. So, okay, so that's cool. And then also now, instead of searching for terms, so like variable description names that have to do with the flu, the next thing I want to do is I want to search for tables that are related to vitamins, and specifically I just want this kind of just this VIT, because the tables that have vitamins in there probably have VIT somewhere in there. So I'm going to do that. Okay, so that was finished. I'm going to look at it, and you can see it came back with 10 different data sets, and the data files are called vitamin A, vitamin E, carotenoids. That one's probably going to be pretty important. And the most recent one that I have, so you can see, and one thing about Haynes is they always have, the file names always have underscore and then a letter. The first Haynes was underscore A, and then it went to underscore B and underscore C. And so as the years progress, the letters get higher and higher and higher. And so the most recent file that we have related to vitamin A, E, and carotenoids is the underscore D. And so what we'd like to see is from that year, from the D year, do we have, which is 2005 to 2006, do we have information about their common cold or whether they're having the flu? Because hopefully in this file we have vitamin levels from blood, and then in the other file we will have whether or not they had a common cold in the last 30 days, yes or no. Okay, so if you look through these files, what you'll find is there's two data sets. So in the flu in Haynes, if we look through here, HSQD, let's look over here. So there's the variable name that's within the file and the data file name. Okay, so HSQD So there's this question: did you have flu or pneumonia and ear infection that started during those 30 days? So in these series of questions are asking about the last 30 days. And so this is in the health current health status data file, and the specific question that's related to that question is the specific variable that's related to that question is HSQ520. Okay, and that came from the 2005-2006. So what we'd like to do is pull down the data from this file from Haynes and pull down the data from this file. And this is going to be our flu data, and this is going to be our vitamin data. Okay, so I'm going to run both of those. So the nice thing is the Haynes command here is a function that's within the Haynes A package that we installed earlier. And what that does is it goes out, it searches for that file, and it pulls it down and loads it into R for you. So I don't have to go and download it and scrape through it and figure all that. I can do that all here. So what I did with these 2 lines of code is I went out, I found that data set on the internet, I downloaded it, and I imported it into R as flu data. And then I downloaded this vitamin data set and I imported it into R and assigned it equal to this name. So I could go in here and say, I want to view vitamin data. Okay, and of course it doesn't like me for some reason. So let's see what happens there. View vit data. Okay, it didn't like me, so there's a couple of things we can do here. So the view function sometimes is a little bit questionable, but if I do the $sign, because this is a data file, I should be able to go through here and look and say, oh look, so this one's probably vitamin E, right? LBX vitamin E, and you could go and online to Haynes and actually search these specific variable names and find out what they mean. And I know from experience that this is vitamin E. So if I hit enter, you can see I get this kind of list of numbers here that are all these vitamin E levels. Okay, I'm going to clear that out. So okay, these look good, and so now, and again, this is based on experience, there's in each one of these files there's a column called SEQN. This is their specific identification number. And so what I can do is I can merge these 2 files by their identification number. Okay, and so I'd like to do that and create a new data set called full data. And I can do that with the merge function in R. So merge, I type out the name of the data set, the second data set I want to merge, and then by equals, and then both files should have that column in there, the sequence. Okay, so if I do that, of course it is not being friendly today. Let me pause this for a second and troubleshoot. Alright, so we're back. And I was able to get it to work. I needed to restart again. This is not something that typically happens. So, of course, because I'm recording, this has to all happen now. But anyway, if I run this command here, the full data full data equals merge of the first 2 data sets, I get it, and I'm good to go, and I can view it. I can do view full data. Alright, so here we go. We've got our identification number, and I've got all of my different variables from both files. Okay, so I have what they answered on that questionnaire. That's the 520. Okay, so it looks like there's 1s and 2s. Oh, there's even some 9s in here. So I wonder what the various values are for this specific variable. Let's go back here. And what I'm going to do is make a table of the 520 question, which had to do with their flu and pneumonia. Okay? And so if I run this, you can see I have 1s in that specific column. I have 2s and I have 9s. Most are 1s, most are 1s and 2s, and then I have a few 9s. Nines actually turn out, if you go and look at this specific variable on the Inane website, turns out to be missing. So we have missing in the file, we have missing defined by the person given the questionnaire, and then we have ones and twos. And ones are yeses and twos are nos. Okay, and I'm also going to look at another question that's similar, that doesn't have to do with flu and pneumonia, but has to do with the common cold. Okay, and that's this HSQ 500. So I'm going to run that and see if, because the issue is that there's not many people that seem to have the flu or pneumonia. So let me run that and see. Okay, great. I've got more people who've had the common cold, right? There's 1,500 people as compared to just 375, and I still have my missings that I have to deal with, okay? But that's all right. I think what I'm going to do is go with the 500 instead, because it's happening a little bit more often. So rather now than looking at flu and pneumonia, I'm going to say, is there any relationship between the vitamin levels in people and whether they had a common cold in the last 30 days? So I'm going to use the HSQ 500. Next thing I want to do is look at the vitamin A levels. And so to do that, I know that there's a variable called LBX-VIA that tells me about vitamin A. The higher that is, the more of that you have in your blood, and the lower that is, the less of that vitamin you have in your blood. So to access those values, I just do full underscore data, $ LBX VIA, and the autocomplete will work on this too. So if I hit tab, so if I do L and I'm like, I don't remember what it is, I can hit tab and kind of scroll through here and find it. The summary command is going to give you a summary of the values. Okay, so it's going to give us like a 5-number summary. So we have the minimum, so that's 0.7, the first quartile, the median, the mean, third quartile, the maximum, and the number of missing. So there's a lot of missings happening here. Okay. I can also look at a histogram of that. So this is our first example of a plot in R, but I can do a histogram of those values and see what they look like. So if I hit run, you can see here's a histogram. So it looks like it's a little right skewed, right? So we have some pretty high values here for vitamin A. Those must be all those people, using those vitamin pills. And anyway, but this doesn't seem problematic. It seems okay for me. And so let's also look at vitamin E. So I get my 5-number summary and also get my histogram. This is also right skewed. All right, so the next thing I'm going to do is I'm going to create, I'm going to actually do a Ttest, right? Because what I want to know is the people with a common cold, do they have higher levels of vitamin E or lower levels of vitamin E than those that did not have a cold? So what I'm going to do is create a new variable called cold_vitamin A, and I'm going to subset this full data based on their answer to question 500. So did you answer 1 to question 500, which is yes, I did have a common cold, or 2, no, I did not. So there's cold and no cold. So if I run those, I'll get 2 new values called cold_vitamin A and no cold. And then I can plug those into my Ttest. Notice I didn't have to put all those commands here, right? Like before I had alternative and mu and paired. If you leave those off, it's going to default to all of the things that you'll find if you go to help t.test. So if you go to help Ttest, you'll see the defaulted choices here. Okay, and you can also look through what Ttest is. So I'm just going to leave those off, allow the Ttest to do its default thing. So I do TT in Haynes, vitamin A, and then this will print it out. And so you can see I do have a very significant result. This is probably due to the fact that I have a very large sample size, and it's able to pick up on a very small difference. So you can see we have the average for those that had the cold was a 50.5, and those that did not have the cold was a little bit higher. So those that had did not have a cold had 2.5 more units of vitamin A than those that did have a cold. So it seems like vitamin A, higher levels of vitamin A may be associated with whether you've had the common cold in the last 30 days. But what about vitamin E? So let's go and check that. Okay, so I'm going to run these. It's really similar to the code I just ran. And you can see that is also very significant. And the scale here is a bit different. So it seems like the vitamin E is a bit more frequent in your blood. So you have 1082 and 1044. So it's about 40 units higher of vitamin E in those that did not have a cold. Okay, so that's basically a t-test for this data. So we just explored the relationship between vitamin E and A and whether or not people have had a cold in the last 30 days. So I think there's, that's pretty interesting that we were able to do that quickly. It didn't really take that much work. The next thing I'm going to do here is show you how to create a new variable. So this is useful sometimes when the variables that we have are not really formatted the way we want them. So for instance, the problem with the questionnaires, the HSQ500, was that it was a 1 and a 2, and those can sometimes be hard to remember. So what I'm going to do is create a new variable that's going to be the same information as HSQ500, okay? But what it's going to do is it's going to first start off as missing for everybody, and then what it's going to do is for all of the places where HSQ 500 was a 1, it's going to assign the value of cold, and then wherever it was 2, it's going to assign it as no cold. Okay, and that's what this code here does. So what's going on here is it's first pulling out a true and falses, right? So let me run this just to show you. So it's going to figure out where are all the places where it's exactly equal to 1 and return to me true and falses. So you can see true and falses. Okay, this is all the trues are the places where it's equal to 1, all the falses are where it's equal to 2 or something else, and then the NAs is where it was missing. Okay, and then I'm going to then say, okay, all of the places in new var where that's true, give it cold. Okay, and then all the places where it's true that it's equal to 2, assign it as no cold. Alright, so if I run all these, and what I can do is then get my no cold and cold variable. So now I have a new variable that's no longer labeled 1 and 2, but it's now labeled as no cold and cold. Alright? So the next thing is, okay, we did all the t-test stuff for this data, but what if I wanted to do linear regression, where my outcome is the vitamin levels, and I want to know is there an association between cold and no cold on vitamin E and vitamin A. So I can actually use linear regression to do that. So in R, there's a command called LM for linear models, and what you do is you give it the formula of the relationship you want to associate with. So on the left is our response variable, on our right is our independent variable, and we tell it the data. So it's pretty easy to do linear models. So I'm assigning it to LM fit vitamin E. And then I'm going to do summary, and I'm going to get out my results here. And so we can see, just as with the t-test, what the t-test showed me is that if you had a cold, you had about a 40-point drop in your vitamin A levels, or vitamin E levels. Okay. Then I could say, and as we all know, with linear models, a lot of times what we want to do is we want to plot a diagnostic plot of that. And so what we can do is, if I do plot of this, and then come down here and hit enter, it will give me residuals versus fitted and my normal QQ plot. And so this is supposed to fit to a straight line, but it's obviously not. So we're having some issues there that should probably tell us that some of our assumptions of linear models are not being met. So if we do this now for vitamin A, so if I go back up here and I hit run and run and run, LM fit vitamin A. There we go. You can see that for vitamin A, it was about 2.5. There's about a 2.5 drop in vitamin A for those that had a cold. Okay, so that's how you do linear models. The next thing you may be interested in is how do I actually do a plot in R of this information. So I'm not interested in the residual plots, but maybe I want to do a box plot. So a box plot would be necessary here because I have two groups and then I have some continuous values, and I'd like to compare those two. So to do that, you can do plot, and then you do what you want on your x-axis. So there we want our categorical variable, right? On the y-axis is where I want my continuous variable, and then I can also title using the main argument, and x label, I'm going to leave that blank, and y label is going to be vitamin E. Okay, so if I run that, you can see I get my nice box plot. It's a little hard to see because, again, or at least the differences here, it's a little hard to see what's going on in terms of the averages. But what I do notice is those that did not have a cold seem to have these kind of extreme values much more often than those people who did have a cold. So that's interesting. If I can do another one now by vitamin A, but instead now of doing a box plot, what I want to do is see is there a relationship between the vitamin A levels and the vitamin E. It definitely does seem like there's some sort of trend going on here, although not very strong. Alright, so that's the example for in Haynes, how to pull that data down, how to utilize it for both a Ttest, a Chisquare test, and doing some linear modeling with it. The next thing and the last thing we're going to talk about is how to do how to use this table 1 package. So the first thing I'm going to do here is I need to make sure that the variables that I'm going to use in my table are understood in R to be either numeric or categorical. And so what I'm going to do is go through and look for all of the LBX variable names. I'm going to pull those out, and then I'm going to make sure that they all become numeric. Okay. This is a bit of a complicated code right here, but just know that's what I'm doing. I'm basically assuring myself that the numerical values that are in the data set are actually numeric. They're actually continuous values and not categorical. So that's what that does. The next command here, or function, is the create table 1. And this is coming from that table 1 package. And what it does is it takes in a list of variables that you want to summarize. You want some descriptive information about. It takes in the data set that they're coming from. Then it also will do, it will stratify the results in your table based on another variable. So in our case, it's going to be new var. So we want to stratify by cold versus no cold status. And we want it to give us descriptive information about vitamin E and vitamin A. Okay. So if I do that and I run this command, oh, looks like I didn't load that in. So I need to do library of table 1. Okay. Okay, it's now loaded in, so now I shouldn't have a problem, except for there's no package called dplyr. Let me pause here. Alright, and we're back. So we should be good now. I'm going to run table 1. Alright, now table 1, and I called it tab 1, so now I'm going to print that out. And so there you go. Now you can see I've got this nice, beautiful table of the mean, the standard deviation, stratified by whether they were cold or not cold, as well as it spits out here the Ttest that's associated with each. Okay, so I have this nice table, and you can see this is really great because it gives it to me this nice format. I can also write this somewhere into an Excel file, and I could do this for many variables at once. So, and that's exactly what I'm going to do next. Instead of doing just 2 variables, vitamin E and vitamin A, I want all of the vitamins that are in that data set. Okay, and so that's what this line is doing. It's going to pull out all of the column names from my full data that have LBX in them. So here's every LBX variable name, and it's going to assign it equal to vars. Okay, so if I do that and I get vars, I'll get that. And then what I want to do is I want to create a table 1 where with all of these vars from this data set based on this stratification. Okay, so if I run that, only took a second. Now I get this nice, beautiful table based on each vitamin. Now I need to go through and actually figure out what each one of these vitamins are, but you know, from experience, I know this is cryptoxanthin, this is lycopene, I think this is vitamin A and vitamin E, and probably could figure out some of these with some more time, but we can easily go through here now and see the averages and their differences, as well as whether they're significant or not. So you know, the thing is with this type of information is it not only tells you if it's statistically significant, but you can also see the impact, the actual effect that's happening, and whether or not you think that's clinically meaningful. You know, a vitamin E level of 40 may not be really that meaningful, but a difference in, you know, cryptoxanthin of 0.5 might be huge. So that's where you can see this. You also can see, you know, the standard deviations and get an idea of, you know, do I need to be using an equal variance assumption Ttest, or do I need to maybe relax or assume that it's unequal? So that's how you use this table 1. I found that to be incredibly useful for papers. It will spit out lots of information very fast in a nice formatted way. And also I can rerun it based on, you know, oh, I want this variable, I don't want that variable. I don't have to go back and recheck boxes and those types of things. If I want to print that, or print any file, that is, what I can do is use the write.csv function. And so what I want to do is I want to write my CSV, I want to write this table1_a to a file called table1.csv. Now it's going to save this file in my working directory, which, remember, my working directory from before was my R workshop folder. And so I have to make sure that I use this print function around the table 1a. And if I do that, and I use the write.csv, this will write it. And I'll go show you that in a second. So let's run that. So it writes it. Okay. And then if I go over here, you can see it created a new file called table1. If I open it in Excel, here you go. And now I can easily go through here, edit and modify it to my desire. All right, so that's how you write files. And I could write really any file I wanted to from this tutorial. So if I, let's say I wanted to write full data, I wanted to maybe write that data set out, and I wanted to import it into SPSS or Stata or SAS. I could just do write.csv. You list out the thing you want to write, which in our case is full data. File equals, and then in quotes you do full data.csv. Oh, and then hit the run. You can see it wrote it out. Go back here, go to our workshop, and there you go, full data. If I open that up in Excel, I now can go through and look at everything. All right, so that has been the R workshop. I hope you have found this interesting and useful. If you have any questions, please let me know. You can access me via email or comment on this video. Really appreciate you stopping by, and I hope you've learned something. Have a nice day.